Okay, business algebra. I am currently in the process of grading your tests. I expect they'll be done probably this afternoon. But for now, we can start with 9.1, which if you look on Canvas, there's 9.1 and 9.2 notes. 9.1 is the first 4 pages. We'll spend a little time talking about page 1 and doing it. That'll be one video, and then I'll do one example from page 2, 3, and 4 for the second video. So first we need to talk about what a probability distribution is. It's really just a table or a list of outcomes of an event and their chance of occurring. For example, what are the outcomes when you flip a coin? It's heads or tails, so you would list heads and tails, and it's a 50% chance, so 0.5 chance of occurring for each of them. And that would just be like a 2-entry table. Now the sum of all the probabilities in a probability distribution is 1. 0.5 plus 0.5 is 1 in the coin flipping situation. And every entry must be between 0 and 1. Because 0 represents a 0% chance for something to happen. You can't go less than that. You can't have a negative chance of happening. You can't have more than a 100% chance of happening for a single event. So a probability of 1 is guaranteed, and a probability of 0 means it can never happen. So let's just look at that word problem down at the bottom, or in the middle. It says a fun-sized bag of M&Ms has 9 brown, 6 yellow, 7 red, 4 orange, 2 green, and 2 blue candies. Draw a probability distribution in histogram. We'll talk about the histogram in a second, but let's just do the probability distribution. So to do a probability distribution, really this is your part. It's like the chances of it happening, so we need parts of a whole. So let's add all of the numbers together to see how many total there are. So 9 plus 6 is 15, plus 7, 22. 22 plus 4 is 26, 28, and then 2 blues, 30. So there's 30 total. So this is the color. This is the probability in fraction form, and this is the decimal. So we have brown. There are 9 out of 30 of those, which if you do that as a decimal, you can put it in the calculator, that's 0.3. Yellow, 6 out of 30, that's 0.2. Red, 7 out of 30, that's 0.2. We'll go 3 decimal places, 3. Orange, 4 out of 30, which is 0.133. Then we've got green and blue, which are both 2 out of 30, which is 0.067. Okay, so what does this mean? These are just the probabilities, and if you add all of these together, you actually do get 1, and all of them are positive numbers between 0 and 1. That's it. That table is the whole thing, so not too bad. Now a histogram is really just a bar graph detailing this information. The only thing is all of the bars have to touch for a histogram. So if you draw a little bar graph over here, down here we've got color. Here we've got frequency. So if I start with brown, let me label this. We'll go 0.05, 0.1, 0.15, 0.2, 0.25, 0.3. So brown is all the way up at 0.3. So the other thing about histograms is all your bars are supposed to be the same size. So brown is 0.3. Next color is yellow. It's at 0.2. After that, we've got red. It's at 0.23. And we've got orange at 0.133. Then we've got green and blue are both 0.067, which is about here. And that is a histogram. So not a whole lot of special anything going on there. It's really just a table and a bar graph, just with some slight changes, like you have to have all these even widths and they all have to be touching. So I don't think anyone should struggle too much with that. Just remember that a probability distribution, you take, if you have the numbers here, you take them and you divide them by the total to get their chances of occurring. Basically, what it means is if you pick one M&M out, this is your chance of picking each of these colors. 9 out of 30 chance of one M&M being picked being any of those colors. And of course, there's an 100% chance you pick some M&M of a color, unless, of course, like this is the same factory that Skittles are made in and someone accidentally misidentified a Skittle and put it in your M&M bag. Probably didn't happen. So I don't think we have to worry too much about that. You notice that there's no probabilities of 1 or 0 on your table there. What is the probability of 1? If I asked you what's the chances of picking an M&M out if you pick one thing from the bag, be a probability of 1. Probability of 0, if I asked you what are your chances of getting a hot pink M&M out of the bag, well, there are no hot pink M&Ms, so that would be a probability of 0. Now the other part of this chapter is expected value, and it kind of piggybacks off the probability distribution. It's the sum of all probabilities times their chance of occurring. So this usually requires that whatever things, instead of just colors, that there's a number value attached to the thing that you're drawing. So for example, if I told you that a brown M&M was worth 5 points, that would be a number attached to it, and then you could calculate your expected point value, something like that. So the most basic one is with money. A $20 bill, 2 $10 bills, 3 $5 bills, and 4 $1 bills are in a bag. You will draw one. What is the expected value of the bill you draw? So on your notes, you see this thing. You see the sum. That means the sum of all. And then it says x times probability of x. So we're going to start with an x. That's what is happening. And probability of x is the chances of it happening. And this is, we're going to multiply them together. So I'm going to take those two columns and multiply them together afterwards. So I asked myself, what are my options here? What can I possibly draw? I could draw a $20 bill, which is worth $20, a $10 bill, a $5 bill, or a $1 bill. Now P of x is the chance of drawing that bill. How many total bills are there? There's 1 20, 2 10s, 3 5s, and 4 1s, which is 10 total bills. So what are my chances of drawing a $20 bill? Well, there's one of them out of the 10 bills. What are my chances of drawing a $10 bill? There are 2 of them out of the 10. Same for $5, 3 out of 10, and $1 bills are 4 out of 10. Notice that if you add all of these probabilities together, you get 10 out of 10, which is 1. So this is also a probability distribution. Now it says I'm supposed to, this means the sum of all, but I have to multiply these first and then I will add them together. So what's 20 times 1/10? That's the same as 20 divided by 10, which is 2. 10 times 2 tenths, that's 10 divided by 10, which is 1, times 2, also $2. 5 times 3 tenths is 15 tenths, which is $1.50. And 1 times 4 tenths is 40 cents. So what does this all mean? Well, it means on average, towards the expected value, the $20 bill is contributing $2, $10 bill, $2, $1.50, and 40. So to find the total amount everything is contributing, you add them all. So you had 2 plus 2 plus $1.50, so that's $4. That's $5.50 to get $5.90. That means the expected value of what you draw from this bag is $5.90. You're like, well, that's impossible. I can't draw a bill for $5.90. This is really the expected value over the long run. It's really kind of like the average value of the bills in the bag. And we'll do more in the next video.